Hi, this is section 5.4. We're on page 311 to start, and this section is entitled Writing Linear Equations in Standard Form. Now, this is going to be a two-day section, and there's four major things that I'm going to have you understand how to do in order to complete the section. I will get to those four major things in just a minute, but I wanted to start off with reviewing what standard form is. Now remember, standard form is an equation of this form: ax plus by equals c. This is what standard form looks like. An example of standard form could be like 2x plus 5y equals 13. Now remember, we now have three different forms of equations for linear equations. Slope-intercept form, we have point-slope form, and of course we have standard form. Now standard form we've actually used earlier this year. Remember, we used standard form. It was really easy to find the x and y intercept of a graph. When our equations in standard form, to find the x-intercept, you just plugged in 0 for y and solved for x. And to find the y-intercept, you plugged in 0 for x and solved for y. So standard form is what we're working with today. We're writing linear equations in standard form. Now, I said there's four major things we're going to need to do in this section that I'll need you to understand. So I'm just going to put them up here, and we can just walk through each one of these. I'm going to need you to write an equivalent standard form equation. We're going to talk about that first. We're going to need to write a standard form equation if we are given points, a graph, etc. I will talk about that in my video. If I give you 1 point, we need to be able to write the equation of a horizontal or vertical line that goes through that point. That's a third task we'll need to do. And the final task would be to find the value of a missing coefficient in standard form. Those four tasks, each one of those we will need to be able to do. We're going to talk about this first task. I'll keep on going back to this slide, but let's talk about the first task, writing an equivalent standard form equation. That's very simple to do. Here's what has to happen for you to write an equivalent equation in standard form. Okay, now remember, equivalent equations mean they just basically look different but have the same solutions. You can create an equivalent equation by just multiplying or dividing each side by the same amount. Let me just review equivalent equations real quick with something very simple, and I'll do it down here in the bottom corner. Like, let's say you had a simple equation like 2x plus 10 equals 50. Now remember, when you solve, you took away 10 from each side first, and you'd get to here, 2x equals 40. Now put a little star next to this. This equation is equivalent to that one. And then you'd divide each side by 2, and you'd get x equals 20. Well, this equation is equivalent to the other two. Now remember, equivalent means this. If you plug in 20 here, this is a true statement. If you plug in 20 here, 2 times 20 is 40. That's a true statement. If you plug in 20 here, 2 times 20 is 40 plus 10 is 50. Equivalent equations mean, even though they look different, the same value for x will solve or be a solution to each one. Every one of these equations are equivalent. Okay? So when I give you an equation like x plus 3 equals 4, and I want an equivalent equation, all I'd have to do is divide each side of the equation or multiply each side of the equation by the same amount, and I will create an equivalent equation like, and remember, this is in standard form, I'm just showing you that. Here would be an example of an equivalent equation. Like, let's start with this one, 2x plus 2y equals 6. I doubled everything. Now let's think about this for a minute, okay? I think you'd all agree that if x is 2 and y is 1, 2 plus 1 is 3. The point 2, 1 does satisfy this equation. Now let's try, does it satisfy this one? If you plug in 2 for x and 1 for y, look what happens. 2 times 2 is 4, 2 times 1 is 2, and 4 plus 2 is 6. This point satisfies each equation. These are equivalent. Or here would be another equivalent equation if I just tripled everything. 3x plus 3y equals 9. That's an equivalent equation. Or if I divided everything by 2, half x plus half y equals 3 halves, that'd be equivalent. Or if I multiplied everything by 8. Any one of these would be correct answers. I just need one of them. I wanted to write an equivalent equation. And you'll see in your homework that's the first thing they'll ask you to do. Like if you go ahead to page 314, the first block of problems, 5 to 10, is just you writing equivalent equations. So for example, like in number 8, you can see that number 8, it's negative 9x minus 12y equals 6. And the directions are to write two equations in standard form that are equivalent. Well, here's a couple of equations. One would be if I divide everything by 3, I'd get negative 3x minus 4y equals 2. That certainly is equivalent. Or maybe I could double everything, like negative 18x minus 24y equals 12. There's two equivalent equations. They asked for two in the directions. There's two. Obviously, there's plenty more. Here's another one. If I tripled everything, I'd get to here. Or if I just multiplied everything by negative 1, look what would happen. I get positive 9x, positive 12y, negative 6. I just need two. I actually gave you 4. So that first block of problems, that's what they're asking you to do. Now, we just covered how to write an equivalent equation, which was task number 1 on the list here. Task number 2, write a standard form equation if we are given points, a graph, etc. Okay, now, I've had parents ask me about this, so if there's any mom or dads watching, the way that I teach this is just the way the book is showing it. That way, if your son or daughter has any questions, I'm showing exactly what the book showed. And to write an equation in standard form, I would always start off then writing an equation in point-slope form first. Now, I know sometimes parents have said, well, you can get it by starting in slope-intercept form, I meant to say, and that's correct. But just to be consistent with what the book's showing, so there isn't any confusion, I'm just going to do exactly what the book's showing, and that's, I'll start off in point-slope form. So, let's say that in question 11, if you go to question 11, and the directions are to write an equation in standard form of the line that passes through the given point and has the given slope, or that passes through the 2 points. In question 11, they give me a point and they give me a slope. So I start off in point-slope form. I have a point and slope. So my point, remember, let's just review that. My point, negative 3 gets plugged in for x. 2 gets plugged in for, well, x sub 1 and y sub 1, I should have said. And my slope, and I don't have another, well, I'll use red even though this is not in, well, I'll just use black. I don't want to screw anybody up. My slope, you can see, is 1. Okay, once you have point-slope form, all we need to do to write an equation in standard form, after you have point-slope form, distribute the 1 through, get x and y on one side and the constant on the other, and you will have standard form. So let's do that. I'll distribute the 1 through the equation, which gives me y minus 2 equals 1x plus 3. I'll get all the x's and y's on one side. I'll put all the x's and y's on the left. So I'll take away 1x from each side to get rid of 1x from the right side. And I have negative 1x plus the y minus the 2 on the left, and I'm left with positive 3 on the right. Now, I got to get the constants on the other side. There is a constant here, this minus 2. I don't want this minus 2 here, so I'm going to add 2 to each side. And when I add 2 to each side, I have the negative 1x plus y all alone on the left, because these cancel, and I have 5 on the right, and do you notice there's my standard form equation. So it's very simple. Just start in point-slope form. Plug in your slope, plug in your point, distribute, get all the x's and y's on one side, get all the constants on the other side, and you will have a standard form equation. We'll do another one of those. Let's go to 14. They give me a point and they give me the slope. So we'll start off real quick. Here's my point. Negative 8 gets plugged in for x sub 1, as you can see. 0 is getting plugged in for y sub 1, as you can see, and my slope of negative 4, you can see that was plugged in for slope. Okay, well, simple. Distribute. Get all the x's and y's on one side. I'll add 4x to each side to do that. And my constants are all on the other side already. Well, there you go. There's my standard form equation. 4x plus y equals negative 32. Very simple to do. Question 17. Now in question 17, they don't give me the slope. They give me 2 points, and that's it. So I need to get the slope. So here's a little review. Let's use our slope formula. And I'll call this point 2 and this point 1. I'm doing negative 4 minus 4 for my y's. That's negative 8. I'm doing 4 minus negative 8 for my x's. That's 12. And negative 8/12 is negative 2/3, which I'm going to plug in for my slope. You can see I plugged in negative 2/3 here for my slope m. Now I need a point. Doesn't matter which point I pick, so I would pick the easiest point, and I'll just plug in positive 4 for x sub 1 and negative 4 for y sub 1. Doesn't matter what point I pick, I'll get the same equation either way. I'll do it both ways so you can see that. So I have y plus 4 equals negative 2/3 x minus 4. Now, distribute. So I'm distributing. Get all the x's and y's on one side, so you can see I got all the x's and y's on the left, so when I add 2/3 x, these cancel, and I have 2/3 x plus y plus 4 on the left and 8/3 on the right. And then we take away 4 from each side, and 8/3 minus 4 on the right is negative 4/3. Now, one thing in the state of Michigan and part of the Michigan standards for this is when we write an equation in standard form, we are not supposed to have a and b be anything other than integers. A and b must be integers. Okay? Well, if you look at my equation that I have circled in red, okay, 2/3 is not an integer. So what I can do to get rid of the divide by 3, I can just multiply everything by 3 to get rid of the third. And remember, when I multiply everything by 3, this is just writing an equivalent equation, which is just what you practiced in step 1 of my 4 things that you needed to know. So if you just multiply everything by 3, you'll get 2x plus 3y equals negative 4. Now this is correctly written in standard form. We want a and b to be integers. As you notice in my original work, a here was not an integer. It doesn't matter, I guess just to keep my video short, I'm not going to actually plug in negative 8/4, but what you will find is if you plug in negative 8 here and positive 4 here, when you distribute the negative 2/3 through and work this whole thing out, you will get the exact same equation. Okay, one more just to make sure we got this down. Number 16, they gave us a point and they gave us a slope, and they want standard form. So remember, to write a standard form equation, the first thing we must do is get our point slope form written out properly, which I'll do right now. I'm plugging in a sixth, I meant to say, for my slope. And x sub 1 is negative 6, and y sub 1 is negative 10. And let's distribute and simplify. I have y plus 10 here, add the opposite. Over here I have x plus 6. I'll distribute through. That's y plus 10 equals 1/6 x plus 1. Let's get all my x's and y's on one side. I'll take away 1/6 x from each side. And I get negative 1/6 x plus y plus 10 equals 1. And then I can subtract 10 from each side to get all the constants on the other side. And I get negative 1/6 x plus y equals negative 9. Now remember, I can't leave this like this. I do not want a or b, my lead coefficients. Remember, in standard form, State of Michigan standard, as a teacher, I'm supposed to be telling you that A and B, when I write a standard form equation, must be integers. That means you can't have fraction or decimals here. Well, I can't have the negative 1/6. What I could really quickly do, if I multiply everything by 6 and write an equivalent equation, I'll get negative 1x plus 6y equals negative 54. There's an equivalent standard form equation where A and B are integers. We'll do one last one just to make sure you got this down. Question 22, they give me 2 points. They want a standard form equation, so I got to get the slope first, so I'm doing that here. I'll call this point 2, and I will call this point 1, and negative 2 minus negative 2 is 0 in the numerator, and negative 1 minus negative 6 is 5 in the denominator, and 0 over 5 is 5. So my slope is 0. Well, that's nice, because when you plug in 0, anything times 0 is 0 on the right, and on the left side, I'll just pick this point here. I'll plug in negative 2 for y sub 1, and y minus negative 2 is really the same as y plus 2 equals, now remember, since this is 0, 0 times anything is 0. I got to get all the x's and y's on one side, and I want the constants on the other, so I'll take away 2 from each side. I get y equals negative 2. This is in standard form. Now, you might be like, wait a minute, this is not in standard form. This is what standard form looks like. Where's the x's? Well, this is standard form. What you really have is you have 0x plus 1y equals negative 2. We don't normally write the 0x down, so it's not there. As you can see, nothing there. And we normally don't put the 1 in front of the y. This is definitely standard form. Okay? Moving ahead, let me go and just go back to my first slide real quick. My very first slide, remember I said we had 4 tasks, and we got the 2 big ones out of the way. We wrote an equivalent standard form equation, and in the last several slides we showed you how to write a standard equation if we're giving a given points, graph, etc. Okay? Now, the next thing, given 1 point, we need to be able to write the equation of a vertical or horizontal line to that point. That's very easy to do. I can show you that in basically 2 quick slides. Okay? And you don't even need graph paper, but I have this graph paper out because this is what I'm thinking in my head. Look at number 23. They want the equations of the horizontal and vertical lines that pass through the given point. So the given point's 3, 2. So this is not on paper. This is what I'm thinking in my head. I'm picturing this in my head. Okay, you can see here, I don't need graph paper, just picture in your head. Here's the point 3, 2. Okay, the horizontal line passing through that point would be right here. Can you see it's y equals 2? The point is 2 units up. That's the line y equals 2. Okay? The vertical line going through this point would be 3 units to the right. That's x equals 3. Should be very easy for you to just picture in your head what's the equations for the vertical and horizontal lines through a given point. So when you do number 24 and you have negative 5, negative 3, remember, this is in my head. I'm not actually doing this on paper. In my head, I'm thinking the following. I'm thinking, oh, I have graph paper, and the point negative 5, negative 3 is like over here somewhere, which means the horizontal line going through that point from left to right is down here at negative 3, and the vertical line going through that point is over here at negative 5. So I'm not actually doing that on paper. I'm just thinking it in my head. I got negative x is negative 5 is the vertical line. The horizontal line is y equals negative 3. Okay? So that's the third major task I had to show you. I'm going back to that first slide one more time here, just rewinding this as I'm talking to you. Okay? So I have just showed you how to do the third major task of the section 5.4, which is writing equations in standard form. If we're given a point, you should be able to easily write the equation of the vertical and horizontal lines to that point. And then the last thing I need to show you is how to find the value of a missing coefficient in standard form. So a missing coefficient, That would be questions 31 to 36 at the bottom of page 314. Okay, so let's do that. I want to find, oh, I went too far ahead now. I want to find the value of A in question 31, and they gave me a point. Well, this is very simple to find. Remember, a coefficient, the word coefficient, recall, means the number in front of the variable. I want to find the value of the number in front of x in question 31. Very simple. Take 2 and plug it in for x. Take -1, plug it in for y, which gives you 2 times a plus, well, over here, 3 times -1 is -3 equals 5. All you got to do now is solve for a. Very simple. Add 3 to each side. 2a equals 8. Divide each side by 2. A equals 4. Okay, part 1's done. You figured out a is 4. You found the value of the coefficient. Now it says write the completed equation. Don't forget to do that. The complete equation then would be 4x plus 3y equals 5. You can see I just replaced a with 4. Very simple. Question 32, same type of deal. Take 6, plug it in for x, 1, plug it in for y. That gives you 6a plus -4 equals -1. Or I guess you could think of it as 6a minus 4 equals -1. Add 4 to each side, which gives you, turn that layer on, which gives you 6a equals 3. Divide by 6, a equals half. Don't forget to write an equation. Part 1, a equals half. Part 2, plug in half for x, which gives you 1/2 x minus 4y equals 1. Now remember, we can't leave this like this. I don't want half x. I don't want half for a lead coefficient. Standard form, I need integers. So if I just quickly multiply everything by 2, that will happen. 1x minus 8y equals -2. There's an equation in standard form. I'll just quickly run through one last one with you. 33. -x, -1x that would be, plus by equals 10. Well, plug in -2 for x. The point was -2, -2. Plug in -2 for y. You can see that was question 33. That gives me +2 plus -2b equals 10. And then from there, of course, we'll take away 2, which gives me -2b equals 8. I'll divide each side by -2. That gives me b equals -4, and then my standard form equation would be that. Okay? I'll stop my video there. It's been long enough. Any questions, we can talk about that tomorrow.